the European Association for the Study of Science and Technology. And I'm Marijke Smolka. I'm one of the co-organizers. I've been organizing this with Erik, Cynthia, and Erik from ASU, but also with a number of co-organizers from different institutions across Europe, some of which are also here today. So thank you also to the co-organizers for advertising our seminar series. So to remind us all, the mission of our seminar series is to create a STEER community, to learn from one another, to connect, to grow, and also to extend it. And for those who need a refresher, there are 3 methodological components to STEER: the decision protocol, the embedded humanist, or more broadly an ethos of engagement, and the analytical framework of midstream modulation. Together, these components help us collaboratively describe normal expert decision-making processes in real time. So what is the objective of this? We engage in collaborative processes primarily to understand the nature and limitations of expert capacities to participate in broader frameworks and systems for the normative governance of research and innovation in society. Another aim is to explore the scope for expansion of these decision capacities. And finally, we seek to deepen these capacities where appropriate. However, we are very careful here. We avoid to impose normative concerns and frameworks on our STEER participants, but instead use probing questions to shed light on alternative values and value considerations. As you know, the STEER community has been very active over the last decades. So there have been 80 studies which were conducted on 4 different continents. And a number of scientific articles and reports have documented the result of these studies. And some of these articles are actually presented in our STEER seminar series. This month, I'm very pleased to welcome Dr. Erik Fischer, who has moderated the STEER seminar so far and will today give a presentation on being surprised by the practical effects of STEER. Dr. Fischer is an associate professor in the School for the Future of Innovation in Society and the director of the Center for Responsible Innovation at Arizona State University. He is also the editor-in-chief of the journal Responsible Innovation. Dr. Fischer is of international renown for his contributions to discourses on anticipatory governance, responsible innovation, and public interest technology. He's the developer of the STEER method, which was created over 2 years in collaboration with researchers in the Thermal and Nanotechnology Laboratory at the University of Colorado in Boulder. Today, he will present the first STEER pilot study, which was published 2007 in Nanoethics. Since then, he has given STEER workshops across the globe and has co-authored numerous STEER studies, the most recent one together with one of his students and our seminar co-organizer, Cynthia Pickering. So Erik, the floor is yours.
Thank you so much, Marijke. It's great to be introduced in the seminar series and to participate, and I'm really glad that everyone was able to come and attend. So let me start the presentation, and we will take questions after I'm done and have a discussion. But feel free to put things into the chat, and I'll either try to respond in real time, or Marijke and I will keep track of them and get to your comments and questions when I'm done. So without further ado, the title of my talk today is on being surprised in socio-technical integration research. And I want to begin with a paper published in 1960 by the Nobel Prize-winning physicist Eugene P. Wigner. Wigner, who is Hungarian, was Hungarian in birth, published this paper called The Unreasonable Effectiveness of Mathematics in the Natural Sciences. And what he had in mind here was a phenomenon that sits at the heart of mathematical physics, namely basically the phenomenon of what many people call the laws of nature. But Wigner was sort of puzzled and in great wonderment at the idea that a mathematical structure could be developed in one case to describe, say, the motion of a free-falling body on the surface of Earth, and then it could be called gravitation. And then at some point later in time, this same mathematical structure proved to extend so as to accurately model the motion of planets. And Wigner lists a number of these cases. Many more people after him have listed many cases such as this. And Wigner summarizes this sort of unreasonable effectiveness of mathematics by saying that the mathematical formulation of the physicist's often crude experience leads in an uncanny number of cases to an amazingly accurate description of a large class of phenomena. Now, in these days of big data and machine learning and freakonomics, it may not seem noteworthy that this phenomenon occurs, but I think it's worth appreciating it, and if nothing else, marveling at Wigner, marveling at the surprising effects of scientific research that such cases have proved accurate beyond all reasonable expectations. They're truly surprising, and he even goes so far as to say it is difficult to avoid the impression that a miracle confronts us here. So I think it's very interesting. We can certainly talk about the importance of surprise in both quantitative and qualitative research. I think anyone who's gone through the research process knows that it's almost inevitable that there will be surprising results. But I really want to bring this idea into collaborative interdisciplinary inquiry, and particularly the unique form of it that STIR supports. And I want to talk about the importance of surprise by really focusing on what in a way was the original surprise in STIR that I think on some level has not gone away, at least for me. It remains a surprising phenomenon. And I want to share that surprise with you as potential STIR practitioners or actual STIR practitioners, and to encourage us to retain the capacity and cultivate the capacity to be surprised, not just because it will help us do better research, but I think there's also a sort of socio-political value to what I'll talk about as suspending belief and suspending expectations. So the surprising fact, or if you want, miracle about STIR is that what started out as a method for assessing something turned out to be an effective method for intervening into that very thing. And what we're talking about here is, if you think about what STIR stands for, Socio-Technical Integration Research, well, that suggests that STIR is research into the phenomenon of socio-technical integration. So what is socio-technical integration? This is a contested topic. STIR was designed in a contested space to investigate this contested topic simply to assess its possibility and utility. But it turned out, I'm going to say miraculously, and honoring Wigner and to be a little provocative, it turned out miraculously to be an intervention that supports socio-technical integration. So as most of you know, or many of you know, STIR routinely, in STIR studies, has been associated with the production or the support or the documentation of what we call modulations. And without going into these at length, there's three typical types of modulations, and they tend to be sequentially related. Changes in awareness by the scientific practitioner who's participating, changes in their thought, and changes in action. However, even though these things are typical, expecting them to occur can actually cloud the investigation. So there's something of a tension, or I don't think it's quite a dilemma, because I think we can resolve it, but it's closer to a paradox than a dilemma, but we can just call it a tension. That on the one hand, I think everyone in this seminar probably either believes or is familiar with other people who believe that STIR tends to produce modulations. And yet if you're conducting your own STIR study, having this expectation or even having the belief that of course modulations should be produced because they're socially constructed, this can lead to problems. So I want to suggest that it's important to be surprised in our STIR activities and to go over a little bit of two important ways in which surprise has functioned, both in the historical development of STIR as a method, but also in the routine conduct of STIR as a practice. So I want to suggest that surprise in STIR was initially an asset analytically, because it helped me when I was developing and piloting the method hone my ability to discover things, to discover the results and the effects of the use of the STIR protocol. And thus that aided my ability to assess capacities for socio-technical integration. It helped me assess the possibility and utility of socio-technical integration better. And then over time, as multiple STIR studies started to come online, the continued surprise that I personally experienced whenever any new study came along and it had these modulations, it really led me and the STIR community to help clarify and refine the method so that we could continue to practice it as a research method. But it's more than just a methodological practice. I want to suggest it's a collaborative and a socio-political practice. It's something that can produce productive cross-cultural exchange, which is actually more and more important given the partisan nature of so many social groups throughout so many parts of the world. And one of the longest standing partisan divides has seemingly been an innocuous academic divide between science and the humanities, or social science and engineering, all sorts of different ways to cut that up. But I think it's particularly important to pay attention to these cultural divides and to find productive ways to bring them together without sort of asking or expecting them to agree on everything. And ultimately, in the case of socio-technical integration, it is a deeply contested concept, and this has social, cultural, and political implications. So socio-technical integration is contested both as a concept and as a practice. I think this is not a contested claim, but just in case you need a refresher, let's remind ourselves that calls for integration have historically attended the development of science and technology, right? So ancient philosophers have decried the separation of science from its context of application, right? The idea that scientists don't think about the impacts that their work is going to have. The Romantic poet Wordsworth talks about the importance, if science really starts to colonize the human experience, that the poet should carry sensation into the midst of the objects of the science itself. And, you know, in the sort of post-science policy, post-World War II age, even some of the establishment members of the scientific community who might have been thought to oppose the idea of integration for reasons we'll look at in a moment, famously, Detlev Bronk famously stated that competent social scientists should work hand in hand with the natural scientists so that problems may be solved as they arise, and so that many of them may not arise in the first instance. Okay. However, it's important to notice that as for every call for integration, there are perhaps at least as many calls against integration. In other words, calls for integration have been historically resisted, mostly by the scientific community, but also by the policy community, and interestingly enough, often unwittingly by social scientists and humanists. But here we just have some of the more provocative characterizations of socio-technical integration as alarmist hype, anathema to the core principles of science, rated X for impression. It should be rated X for impressionable young scientists, and it has been seen as violating core science policy tenets. And maybe most famously, and for some notoriously, Polanyi's famous statement in his article, The Republic of Science, where he says you can kill or mutilate the advance of science, but you cannot shape it. In other words, trying to think about and reflect on, let alone take action regarding the social context of science, whether it's the application or the funding or the conditioning of its shaping, for the sake of avoiding unintended consequences, or for the sake of meeting grand challenges, or for the sake of being more inclusive. None of this is really a good idea. It's not possible. And if you try to do it, all you're going to do is kill or mutilate the advance of science. You're not going to get better science, and you're not going to get better social outcomes. However, again, in a nod to Wigner, a miracle occurred in 2003. I think this was a science policy miracle, but it was also a personal miracle for me. I had just started my doctoral program in the fall of 2003, and I had been working on integration and mostly in the classroom, but also a little bit as a science policy concept. And I was wanting to study socio-technical integration, but I wasn't sure how to study it or what the rationale was going to be. And I was casting about, looking for different ways to frame it and different objects of inquiry. And all of my engineering colleagues and advisors were telling me, well, Erik, you should really focus on nanotechnology. You should really focus on nanotechnology. And I'd been aware of nanotechnology since at least 1999, but it just seemed a little bit trendy. That, well, of course, everyone in my situation is going to focus on nanotechnology because that's what you do, because it's a up and coming topic. But is that really going to serve my research interests? Well, the US Congress passed, and the president at the time signed very quickly afterwards what's called the 21st Century Nanotechnology Research and Development Act. And this act really gave me my marching orders. Because not only was it stated in a congressional hearing, in a Senate hearing by a philosopher of technology, the idea that there should be a cadre of scientists, engineers and scholars used to working together, thinking about the social, societal, and technical problems side by side. But this basic idea was enshrined into the authorizing legislation itself of the act. And some of the language is that, Congress has mandated that insofar as possible, integrating research on societal, ethical, and environmental concerns with nanotechnology research and development. So this is a watershed moment because a contested concept, which has never been referred to explicitly in US science policy documents coming out of Congress, and I've looked, right? So it's my claim. It's an open claim for someone to dispute that socio-technical integration as defined, which I'll give you a definition in a moment, it just hasn't been on the radar unless it's been sort of at the lower level of disputation. But speaking of disputation, not everyone in Congress thought it was a good idea. So it's important to remember that even though there was this bipartisan moment and there was this endorsing of the idea of socio-technical integration, at least one congressional member said, well, I'm afraid if you're talking about integration, that you're going to take these, scientists and the physical hard scientists, they're going to be doing their work, coming up with terrific things like nanotechnology. And then so these sociologists say, well, it has to go through this buffer, this filter before it can get to the public. So we see once again that the idea of socio-technical integration, whether because it can mar the practice of science and distract scientists, or because it gives social scientists too much power, or because it interferes with basic principles of, governance as that are under dispute, itself remains a disputed concept, even if Congress has authorized it. And in case you missed it, Congress actually includes a little caveat. In the same breath as they prescribe and mandate socio-technical integration, they raise the question of whether it's even possible. So STIR has matured into a practice with a number of methodological components, one of which is a definition of socio-technical integration. But if you think about it for a minute, how do you define an object of inquiry when that object of inquiry is itself contested? And when the context of inquiry, it can itself be highly politicized. Well, this is how the STIR program defines integration, any activity whereby technical experts take into account the societal aspects of their work as a central or integral part of that work. Now, if you think about it, this definition doesn't say that socio-technical integration exists, doesn't say that it's possible, doesn't even say like that it's a good idea. Okay, why is that? Well, it's because this definition allows for people who disagree or have different beliefs or different expectations or different inclinations or different normative commitments about socio-technical integration to nevertheless work together. And it allows those researchers, those humanistic and social scientific researchers that use STIR in order to assess the possibility and utility of integration, it allows them to do so both in an open-ended and collaborative manner, but also in a credible manner. And I think this notion of credibility is very important because it sort of allows the traditional role of science to continue to play out even in a highly politicized environment. Another way of saying that is that as we know from science policy and the politics of science and technology and much science and technology studies, or STS, science is often, if not almost always, something that can be instrumentalized and politicized, right? So both sides of a debate can use science against one another, right? And this often happens in the well-known dueling expert case. So how is it that science can somehow be credible when everybody has their own scientist, and when scientific results are routinely by both realists and constructivists criticized as being junk science or biased or essentially used to promote what Roger Pielke Jr. has called stealth issues or stealth advocacy, right? So I think that at least in this limited case of collaborative inquiry into the possibility and utility of socio-technical integration using STIR, we can bolster the credibility of the STIR process by, from the very beginning, not tipping the scale one way or the other in terms of whether integration is possible and whether it's a good idea. And there are other ways in which the STIR methodological suite really tries to remain, to structure a space that allows for disagreement, it allows for divergence, but it also allows for the possibility of convergence and agreement. So how do we study socio-technical integration? How do we research it? How do we investigate it? Well, one of the main tools we use is this STIR protocol, the decision protocol. And most of you know that it takes, all right, if you remember the activity, how we define socio-technical integration, any activity, right? So we just take any activity and we say, well, any activity that a scientist or an engineer or a professional or a bureaucrat or anybody else who might be a techno-scientific actor or participant in the social shaping process of science, technology, and innovation is going to have moments, and these could be every single moment, or they might be key moments. This is depends on your philosophy of what a decision is, where they're making choices, they're making decisions, they're taking action, they're deliberating, they're sensing. And in each of these cases, the STIR decision protocol analyzes these moments into 4 different components, decision components: the opportunity, the considerations, the alternatives, and the outcomes. And then the STIR protocol, as a dialogue exercise, then uses this model, this decision model, in order to structure a dialogue that maps the context, maps the decision-making context in any given moment, and it does so over time. So it was originally developed in order to assess the possibility and utility of integration for the analyst, okay? You have to remember that in the time that I discovered the act of Congress, I was also, being reminded of how contentious and contested the concept of integration is, even though it was just mandated. And I was also encountering this at the local level of the laboratory in which I was embedded and in which I worked on a weekly and often daily basis. Okay. And so through a period of what I call productive disillusionment, I realized that I couldn't really, contrary to my initial expectations, come into the laboratory and start helping them enact socio-technical integration or advise them on how to enact socio-technical integration, because they didn't even think they did socio-technical integration, and many of them thought that they shouldn't. As a matter of fact, many of them thought that they didn't make decisions or choices or even take significant actions. So I retreated from my earlier sort of activist normative commitments in thinking that I could figure out a method that would help scientists and engineers working in nanotechnology to do more reflexive socio-technical integration. And I thought, well, you know what, I'm just going to try to get to the bottom of this debate for myself as a satisfying investigation and say, okay, half of the world thinks that integration is possible and useful. The other half thinks that it's impossible or at least a bad idea. Of little to no utility and possibly even counterproductive. So let's just get some good empirical results using qualitative and quantitative measures to sort of stabilize this debate. So STIR was really just developed for me as an analyst to understand what are the possibilities for integration and what would the costs be if the engineers acted on them. But it ended up also supporting reflexive and deliberate forms of socio-technical integration, thus demonstrating its possibility and utility. So what started off as something that was meant to illuminate integrative possibilities for the investigator ended up also illuminating integrative possibilities for the participant. And then the participant would often choose to act on these possibilities, hence creating what we call modulations. Now, those of you who've read the paper know that there are a number of changes that were documented in that paper from 2007, as well as a companion paper from 2006. And in the interest of time, I'm not going to go through all of these, but I did want to take you through just a brief description of how I got to the point where I was able to develop and pilot the STIR protocol, and also to give you a review of sort of some of the central developments in that pilot study. So getting there, I've already alluded to it. It's what I refer to as a period of productive disillusionment, where at first I wasn't even interested in going into the nano laboratory. I was more interested in talking to the PIs and the administrators and the managers and the funding program officers, and looking at written documents and archival research, maybe doing a few interviews. And it was only sort of after a while that I sort of reluctantly agreed to go into the laboratory and start mucking around, to use C.P. Snow's phrase. And this then confronted me with a number of complex factors I had to wrestle with. And I originally thought, as I alluded to, that I would be able to identify the normative dimensions of nanotechnology simply by observing or by asking the scientists what they were working on. And it turned out that over the course of several years, my ambitions and aspirations for a sort of collaborative form of socio-technical integration just melted away. Because I thought, if I came up with something, it would be highly artificial. I would be imposing a process that doesn't exist in the laboratory, and that would, in a nod to Polanyi, it would disrupt them. And it's not clear that it would disrupt them in a productive way. And there were many other things that occurred, but essentially I had to go through this period of productive disillusionment in order to then stabilize my focus, my analytical focus, not on bringing about modulations or how to shape science in the public interest, but simply to understand the possibility and utility of integration, to understand the capacities for integration and what support them, what enable them, what constrain them, whether they're structural, psychological, etc. So as you know, if you've read the paper, there's a series of incidents where I talk about my use of the protocol in about 4 different periods over about a 3 or 4 week time period. And in one case, I met with a researcher in the laboratory and asked, what are you working on now? How's it going? And he told me, K is his sort of pseudonym. He said, well, we're trying to figure out whether we can grow carbon nanotubes in a small silicon fiber. We've been synthesizing carbon nanotubes, as you know, Erik, for quite some time. We haven't regulated the process yet. We haven't made it regular. We haven't normalized it. But, we're able to get this carbon nanotube growth. And we were just challenged. Can you synthesize and demonstrate this growth in a small fiber? And I said, well, that sounds pretty good. What do you have to think about in responding to that opportunity? And Kay told me that they didn't even know if it had any potential application. So this was really just driven. It was a challenge. Why not try it and see? It would be a fun thing to do. So the sort of motivations for doing this were blue sky research. Right, basic science. And this is significant because the laboratory director was a former Bell Labs fellow, and Bell Labs is one of the places where this concept of basic science was really demonstrated and solidified. But as you know from the STIR protocol, the considerations are anything that the decision maker feels he should think about in responding to the application, to the opportunity. And so I kept probing Kay and say, well, what do you actually have to think about when, trying to grow tubes in a fiber? And he said, well, we have all sorts of physical properties we need to think about, and chemical interactions, and instruments and apparatus considerations. So we talked about some of those. And then I took us down to the alternatives, and I said, well, what are your lines of action? What are your courses of action that you could take? And Kay's mind at that point, he went to a more specific aspect of the experimental design. Instead of speaking at a higher level about how to come up with an experimental design, he said, well, we have a chemical catalyst in the experiment, and we have to decide on what the chemical catalyst will be. And I said, well, what's it going to be? And he said, I can only think of ferrocene. We always use ferrocene to synthesize carbon nanotubes. Gosh, I'm not even sure if there's a viable choice here. I said, well, okay, fair enough, but is the only way that carbon nanotubes have ever been synthesized using the chemical catalyst of ferrocene? Have other chemists or engineers or material scientists use different chemical catalysts, or could you imagine a different chemical catalyst? And he said, well, actually, maybe ferrofluid could be an alternative chemical catalyst. And so we talked about the differences between them, and various technical dimensions of his decision-making process that he was anticipating. And then we went into the final component, and I said, well, what do you think you're going to do? And he said, I'm going to just conduct the experiment using ferrocene. So we wrapped up that STIR exercise, and I went home to analyze my data, and then met with him a few days later to do another STIR exercise. At this point, we were doing about 2 STIR exercises a week. So I think this first one occurred on a Friday, and I came in on a Monday. I said, hey, Kay, how's it going? You said that you were going to conduct that experiment over the weekend. Did you do it? Yes, I sure did. Well, what did you use? I used ferrocene. How did it go? It was a failed experiment. Oh, that's too bad. What else happened? Well, I presented the results of the failed experiment, and the laboratory director said, this is a bad idea. Stop wasting your time on this. You need a different dissertation topic. So I said, well, that's too bad. I guess we'll be doing our stir exercise on a different decision, won't we? We're not going to be talking about growing tubes in a fiber. So we analyzed something else. We mapped out a different decision. And um, actually, before we mapped that out, I said, hey, before we start this new stir exercise, I did have a couple follow-up questions from the previous exercise, just for my notes as my analysis. He said, oh, shit, what are you talking about, Eric? I said, well, when you said maybe we could use ferrofluid, you then said, then we wouldn't need to use ferrocene. And I only caught that when I listened to the audio recording and I was transcribing our stir exercise. He said, yes, I remember saying that, Eric. And I asked him, well, why did you say that, Kay? And he said, well, because ferrocene is messy. So I wrote down ferrocene is messy. And then we went about our next stir exercise. I went home and I realized that I didn't know what he meant by messy. So then we met again, probably on a Friday, and I said, hey, let's do another stir exercise. But before we do that, I've got another follow-up question. What did you mean by messy? And he said, oh, well, messy means that it's hard to measure it. It's hard to get an accurate measurement. And we sort of talked about that. And we talked about the equipment. He said, it turns out that ferrocene gunks up the equipment. You can see this crystal tube gets sort of brown, and that degrades its life. And that means that we're going to have to buy a crystal tube more quickly than we'd like. And the more we talked about it, it turns out he also had some concerns about what I thought of as worker safety. And he referred to a potential leak in the apparatus and the Y valve here. And we were talking about, well, why is that an issue, Kay? Why do you think that might happen? And why, what do you think about it? And he was worried about it, as I said, for worker safety reasons. But we also were walking around in the laboratory following the ventilation system to see where it goes. And, Kay was nervous that there might be these leaks, these gas leaks that were not only contaminating the workspace, but going out into the environment and either endangering people or, trees and fish. So there was a lot packed in to his throwaway comment of messy, and a lot packed in to his throwaway comment, then we wouldn't need to use ferrocene. A lot that came out of this idea of maybe I could use ferrofluid, even though he could only think of ferrocene at the beginning. So we were both a little bit surprised, these sort of unfolding discoveries. But what was most surprising is that we did our stir exercise that day on something else. And then when I came back and I said, hey, what have you been working on? He said, well, actually, I went and I got some ferrofluid. And I did the experiment, even though I wasn't supposed to, and I got really great results. And I showed them to my lab director, and he said, okay, let's move quickly. You can now work on this. This can be your focus. And so in Kay's words, it's actually turning out to be something. So that was, an interesting set of modulations. And I wrote about it in this paper that you all know about. However, after that paper had been finalized and sent off, I found out through an email that I received from the mechanical engineering department at CU Boulder, I was now in Arizona, that here was Kay defending his thesis, and he was talking about using ferrofluid as the catalyst and growth inside quartz tubes and fibers. So essentially 18 months after the study was concluded, the sort of surprising turns that occurred during the study were continuing to ripple out. And I actually flew back to Boulder, Colorado and interviewed him. And I said, look, do you still believe everything that we said before about how the project would have been could have been a totally different thing if we hadn't been using the STIR protocol? And he said, absolutely. So I did a lot of thinking and discussing about, what were the factors that enabled this shift in integration to become more reflexive and more deliberate. And what I want to focus on today is the idea that one of the enabling conditions that the protocol sort of introduces, if it's used in a methodologically specific manner, is this idea of open-ended inquiry, probing and inquiring. And so open-ended collaborative inquiry we can talk about what it means, during the discussion period, but I think a few things that it means is that issues are not defined in advance, normative issues in particular. We focus more on inquiring than informing. So the social scientist doesn't say, well, let me give you a lecture on social construction, or let me give you a lecture on social shaping of technology, or why governance is important, or why the social is always mixed into the technical. Right. And rather than really trying to steer or influence the decision-making process of the scientists and engineers who participate in our studies, we really want to just probe their capacities, not prime them. And maybe most apropos of today's talk, I think it's important in open-ended inquiry that both sides, all members, all participants in a STIR exercise suspend their belief, or as it may be, disbelief. Okay, so it may be that the social scientist has to suspend her belief that integration is possible and a good idea, whereas the material scientist might have to suspend his belief that integration is probably not possible, or if it is, it's not a good idea. Okay, these are just stereotypical possibilities, but they tend to pop up a lot. And you can say, well, that's well and good, Erik, when you were doing your STIR pilot study, because you didn't know it was going to have these effects. But what about the rest of us who know about your pilot study? I would say that we want to suspend belief in each particular setting about whether integration is possible or useful. And indeed, as Marika mentioned at the beginning of the talk today, there have been dozens and dozens of known STIR studies, and in every case, right, they tend to produce modulations. And so not only was this it continues to surprise me that whenever a STIR study produces modulations, I just wonder at it. It's just really sort of a fascinating thing to me personally, but also as a research method, it's something that the entire STIR community, we have to remember the R in STIR. Remember that STIR is primarily a research practice, and thus we don't know what the outcomes are going to be. So whereas in my cases, in many of our cases, we have to suspend our belief that might attach to certain social scientific theories of scientific practice. Now, as a STIR practitioner who's aware of the history of STIR, you have to suspend your expectations for modulations to occur. And this is sometimes a difficult thing to do, but I think the technique is to really focus on the process itself rather than on the outcomes. So focus on the method of dialogue, focus on the process of observation and the techniques of analysis. In other words, focus on the object of inquiry, which for the STIR investigator is decision capacity or integrative capacity. However, it's a collaborative inquiry, so the STEM or social science or natural science practitioner who's collaborating may have a different object of inquiry. However, both collaborators are using a shared frame, the STIR protocol, and the techniques that go along with conducting that exercise. It's sort of, I'm calling it a shared descriptive frame. And so by focusing on the frame and the shared descriptive frame and the process and the objects of inquiry, it makes it easier for one to allow oneself to be surprised at any outcomes. So suspension of belief or expectation, I think, has a number of advantages. One is to support dialogue, to build social capital where I believe it's needed, and to deepen what it means to have cross-cultural exchange. How does it do this? Well, by essentially avoiding divisive mindsets and language and dispositions. It also allows for sensing new possibilities for how things could be different and to imagine how they could be performed differently by helping us stay open to unexpected and unfamiliar ideas. And finally, it's, perhaps ironically, it's more likely to bring about the very effects that help us assess integrative capacities. Essentially, the modulations that are likely to occur in any given STIR study are more likely to occur if they're not expected, they're not adhered to, they're not focused on as desiderata, but simply as phenomena that may or may not occur and that we want to understand rather than to promote. So thanks for your attention, and I look forward to your comments and questions.
Yeah, many thanks, Erik. So I would like to open the floor for questions and comments. Yeah, feel free to raise your hand or to put something in the chat if you have an unstable internet connection. And I already see a hand by Christian. Please go ahead.
Hi, Erik. I hope you're doing well. Hope everybody's doing well. I have a question regarding the definition of socio-technical integration that just came up. Sometimes we say when we're doing a definition that what is being defined shouldn't be part of the definition. And here, there's this word that it's integral. When you say that what they take into account should be integral part of their work. So I wonder if we could go a little bit deeper in what does integral means within the definition, because it's already part of socio-technical integration. So I don't know what.
I couldn't agree more, Huga. I think this is definitely the central weakness of the definition, and it needs to be revised. I've been loath to revise it because I can't find a single word that works better. But I agree with you. And so the word that I'm using these days is central, right? As a central aspect. Now we could also say as a substantive part. But instead of saying as an integral part, we could say as a central or a substantive or substantial part. Now, I've thought about dozens of words. One word was formal, as a formal part, but we can't say formal because this then demands that those who practice integration say that they practice integration, and this is just not going to happen. So I think it's important to recognize that what I meant by integral was that there would be a tacit, but nonetheless tacitly endorsed presence in the scientific and engineering practices, where the sensing, the learning, the thinking, the action that is done that is not purely technical. It has sociological, cultural, historical, psychological components to it, that somehow this fact isn't formally acknowledged, right, by the scientist who's participating, but the effects, the act of acknowledging these things and acting upon them is seen to play a central role in that person's work.
Okay, thank you. Then I have Peter Stegmaier.
Yeah, hi, thanks, Mareike, and good to hear you again, Erik. You presented this example again, now interpreted as an open and collaborative inquiry. And I was wondering whether we could take that as an opportunity to further define or specify the actual collaborative activity going on, and maybe get a little bit behind the miracle, why STEER from time to time has such phenomenal effects, such great effects, exciting effects, also for those who let you in, who talk with you and to whom you talk and spar with you. And what I'm always wondering is what you just described not some sort of, I wouldn't say only, just in other terms, people who don't subscribe to the STEER approaches, so would maybe simply call it co-construction. There's somebody around who works with you on something, coming from some more or less different strand, and thereby creates a kind of tension which can be productive. And maybe a second aspect, this has to do with a sort of temporary or structural lack in the organization of providing some sparring partner to people working on something, often quite solitary endeavors, especially PhD students, just to spar, to reflect, have some sort of constructive critic or mentor or opponent, strategist or what around, who says, okay, what you're doing here is interesting. Aha, this is a problem, asking for problems, and then say, okay, well, how to deal with that? And through that asking and discussion, something productive comes out of it sooner or later, directly or indirectly. So what's the miracle of that this happens? Is that this co-productive process? And how far is that more a steer, an integration? How far is it this collaborative mutual interest in something?
Yeah, no, I think this is great, Peter. Wonderful question and really important suggestions. My short answer is the two or three conditions or explanations that you've listed are certainly present, but I don't think they are sufficient to explain, right? So the philosophers would say those are necessary but not sufficient conditions. And I'll try to answer by first taking the idea of co-production, which has different meanings, right? There's the Jasonoffian notion of co-production, which is more of a dare I say, metaphysical. It's the sort of simultaneity, the simultaneous ordering of science and knowledge. But that's not what you mean and what we're talking about here. We're talking more about different people, different social groups or actors or agents working together. And bringing in, sometimes this is seen as bringing in another perspective, right? And I would just say that that really just displaces the miracle. Why is it that having somebody from outside the laboratory come into the laboratory, why does that induce reflexivity, right? It still raises this question. We still need a theory or a model or an understanding of why, what is being changed. But I'll also say that empirically, I've looked at cases of stir where there weren't modulations, right? Where someone did a stir study and they didn't get modulations. And it turns out that they weren't using the protocol to structure a collaborative decision process of mapping the context. They were using it more to extract information. It was more of an interview. Or there were other sort of, dare I say, deviations from the method. So it turns out that just putting somebody else into the room who's got a different perspective and having co-production, in stir at least, is sufficient to induce reflexive modulations, but it's not sufficient to induce what we call deliberate modulations, the changes in valuation or the changes in practice. And then in terms of the sparring partner having constructive critique, this is absolutely, what goes on in collaborative research and whatnot all the time, and sort of introducing new ideas. But it's important to say a couple of things here, and that is, first of all, in stir studies, the quote unquote collaborator, the investigator, the stirrer, the embedded humanist, we have all sorts of wonderful names for the person who performs the stir study. This person is not automatically seen as an equal, as credible, as trustworthy, as competent, as interesting. Right? It really takes time for them to get to the point where they can have a shared inquiry, a collaborative inquiry. And they may not really be able to spar in the same way as somebody who's got, a master's or a PhD degree in, mathematically based sciences. So I think there's a different type of sparring, a different type of constructive critique, but it doesn't involve what's typically criticism, right? So there's not really, I didn't get into it, but there's these modes of doing stir, and we really have these sort of very well-defined rules of engagement where we don't try to introduce judgments or suggestions or new ideas. Okay, so whereas typical constructive critique would be, well, okay, I think it's great that you're going to use ferrocene, but if you use ferrocene, then you're just going to encounter all these difficulties that you're really worried about, that you're not admitting to yourself. And I challenge you to just, sit and think about that a little bit more, my friend, right? But I didn't do that because that would violate what we call stir 1.0, and it would send it into stir 2.0, which is no longer a research endeavor primarily. So how do we explain it? How do we explain it? If there's not this constructive critique and there's not this co-production, and on top of that, it makes it even more miraculous that we're not just changing the material practices from a first order perspective, we're also, in many cases in STIR, having a value change, having an expansion of what counts as interesting. So social or ethical values might shift. And this is not something that you would expect when you have two people who are sort of committed to the interesting success of the project talking about it, right? But it does suggest that we do have something alternative that comes in. So I think all the things that you've mentioned, Peter, are important. They play a role, but they're not sufficient to explain.
And what is it then? What's the miracle then? So what's this? What is the quality, the specific quality of that collaboration as open-ended?
Well, I think
is it the structuredness you mentioned?
Yeah. Okay.
Is
So
it a specific kind of decency?
Yeah. I think one of the best theoretical explanations we have is really John Dewey's notion of inquiry. And again, John Dewey's a pragmatist, so he's one could say that he's more interested in doing than thinking. He's more interested in outcomes than he is in sort of traditional theoretical understanding, and Puga can certainly speak to that because he's no pragmatist. So we can criticize Dewey's theory just as we would a Galilean theory, that ultimately it doesn't explain, it only describes on a more nuanced level. But with that caveat, Dewey does have this notion of inquiry, what inquiry is and how it's structured. And he has a very elaborate set of discussions about how inquiry comes about, how it's conducted, some of the things that can influence it. And really at the heart of inquiry is this notion of a problematic situation, that the decision maker or practitioner experiences what Dewey calls a problematic situation. So you could even say that it's an affective experience, or at least it's something about sensing or awareness. So it could be a precognitive disposition. And Marijke has studied this in her previous talk on affect. We can look at it from the affective lens, from other standpoints, precognitive lens, but there's something in the broadening of the horizons. And I'm currently working on the idea that this has to do with sort of shifting one's own, not socio-technical imaginary, which is a socially held collective imaginary, but a sort of an individual imaginary, right? The personal imaginary, the imaginary of the individual expert. This shifts, right? The system that's envisioned, the frame that is sort of internalized. This is something that becomes dislodged. This is productively disrupted. And so, and psychologists and ethicists have talked about this in terms of mental models and paradigms. There's all sorts of language out there, but I think it's a sort of precognitive way of seeing that shifts, but it's not just the seeing shift. There's also this sort of investment. I'm curious about it, or I'm bothered by it, right? I have to be invested in it, right? So it's not just that I sense that something is different from what I expected. I'm being surprised, but I'm happy to be surprised, or I'm angry to be surprised, or I'm bothered to be surprised, right? So I think, interestingly enough, the notion of surprise comes in, but there are these, I think we can specify the one or two or three aspects that have to do in the shift. But again, just because there's the shift and this curiosity doesn't mean that it's going to move forward. I've done some work with Michael Posnick, another philosopher of technology, and we've sort of specified what we see as this sort of shift from curiosity to care and creativity, right? That these three sort of virtues are sort of, if you have them, right, without these, you're probably not going to get the second order modulations.
Yeah, many things. I would like to follow up on this question of what's the miracle here. For one reason is that yesterday I just read a paper about how dangerous it is to actually push these discourses around miracles, right? Especially when it comes to quantum technologies or AI. So I also think in terms of STIR, maybe, is it tricky to always talk about the magic here? Because I've heard that been raised frequently that there is some magic going on. So, I mean, this is something I think you've taking up Erik because it's also in the community acknowledged that somehow there is something magical about it, but I felt there might also be something, dangerous about going into this discourse of not explicating what it is that is so effective in STEER. And that is something I want to link also to the term ethnographic invention, which is the title of the 2007 paper, because invention also brings with it discovery, something very radically new is happening here. So I thought maybe we could talk a little bit about why you use the term ethnographic invention instead of intervention, and what it is that you invented there. Thanks. Yeah.
Absolutely. Thank you, Marijke. I would say that I agree that when we're doing research, when we're doing science, whether it's qualitative or quantitative, that to just make an assertion that, something is magical, it can't be understood, it's enchanted, we want to stay in an enchanted state, well then, it's hard to understand why we're doing science as opposed to poetry, for instance. And so I want to make a strong distinction that I should have made throughout the talk between data gathering and data analysis. Okay, so the STIR protocol is not an analytical instrument. This, by the way, this is another way in which STIR studies that don't produce modulations often use the protocol as a data analytical instrument, not as a data generating instrument, right? So the STIR protocol is intended to structure the collaborative inquiry and the interactions, the dialogue. It structures an exercise, right? And this is a process of discourse and description and writing things down and probing, right? And this is all, some of my students have called this real-time analysis, but I think it's actually important to say, no, this is just a descriptive exercise. And yes, there's some probing going on here. And this is really your job, is to focus on this. But in between these data gathering exercises, then we do what we call incremental analysis. We sort of think about, well, what happened? And that's why I ask, hey, what did you do? Did you do what you said you were going to do? Well, now I'm starting to reconstruct what happened. I'm beginning to move into an analytical mode, but I'm still not trying to explain anything. I'm really just documenting, okay? But then I think when I have enough things that I've documented, then I can start to, look for patterns and whatnot. Now I'm really moving into analysis. And this is happening during the STIR study, another feature that makes STIR unique. We don't just first gather the data, stop, and then start analyzing. We actually begin our incremental analysis early. And that's, another lecture topic. But in any case, once the interactions have ceased, once the data gathering process has ceased, then we absolutely go into an analytical mode. Right, what might be called the scientific mode. Of course, to define science is essentially a fool's errand, especially, among social scientists. But nevertheless, there's a big difference. And I think it is precisely Peter's questions to me, it is my responsibility to answer in general and for each individual STIR study. And each STIR investigator is asked to explain, not just to identify the conditions that lead to the modulations or the conditions that disable them, but also to assess the capacity and to explain why the modulations that were observed. So we absolutely are then thrown back after we use what we call the midstream modulation framework. We're still not done answering the questions. We still have to then explain this. And this is where we have to take up the question, what's behind the miracle? Okay, and there have been different attempts to explain it. I mentioned, the sort of Deweyan approach, and there's, we can go deeply into the science of learning and wonderment and the beginning of philosophy, which both Plato and Aristotle have talked about. And we can go into, there's all sorts of incredibly delicious psychological theories and methods and models that really help sort of say, oh, this phenomenon is going on here. But again, most psychological concepts and models, they're going to be Deweyan and Galilean in the sense that they don't actually explain causal mechanisms. They just describe patterns at a smaller level, or at least that's a critical statement. So I as you know, have really found great inspiration in the sociology of scientific knowledge and more generally science studies and specifically science and technology studies, STS, there are a number of theories and frameworks that I won't go into here, but that really do help us understand what's going on. And so I encourage all of you, who are doing STIR studies or analyzing other people's STIR studies to continue to draw on the wealth of material we have, but with the understanding that we need to have a generative and dynamic explanation for what's going on, because ultimately what goes on in this miracle is something that there's a lot of dynamicism. And so if we freeze it into a step-by-step operation, we're probably missing the complexity of the operations and the interactions and the changes. And that would certainly be a bad recipe for then designing a policy or a management technique or a pedagogical technique. So things like, I think, again, I'm working on a paper with Jen Richter and Anthony Lavenda. Anthony will be presenting in 2 months, and we're talking about this idea of shifting imaginaries. And how that relates to shifting socio-technical imaginaries, right? Through boundary work and the doing boundary work and undoing boundary work, right? There's all these wonderful sociological and anthropological observations. And I think those are good places to start, but they tend to focus on how inquiry closes down and how discourse closes down and how negotiation closes down. And we need a sort of a new, renewed focus in science and technology studies and in responsible innovation scholarship to focus on, well, how do negotiations open up? How does seeing and valuation open up, right? And we all say that it's important, but most of our theories explain how it closes down or how it doesn't open up. So to actually open it up, what is this process of opening up? But of course, in order to develop these theories, we need examples. And thankfully, STIR has given us some examples. And so I will probably never come up with that theory, but I'll do my best. So you guys have to do it.
Okay, then we have quite some questions in the chat. And since Anna is in the train, I'll try to rephrase, also read out parts of her questions. So one is about the notion of the technical expert. Who is that? She's working with people in the legal field, social lawmakers who work with patient files in Germany. So to what extent could they be considered as experts? I think this is one of her questions.
Yeah, that's a great question, Anna. And on some level, there's a lot of positionality in the sense of the relative, if I can use that word, the relative position of the investigator and or the relative position of who the investigator is studying, right? So what counts as the midstream, right? On some level, any decision is already midstream of a prior structuring apparatus and an expected downstream, right? So we can say similarly with experts, if we wanted to stir a school teacher, well, we might decide that the school teacher is an expert, and so we're gonna treat them as an expert while we're stirring them. That's a little bit unsatisfying, but it's an important point to start with. Basically, I don't think that this notion of expertise should preclude you or anyone from you. If you want to use stir to stir somebody, then you do it, and they just become the de facto expert. Okay, so that's the important thing. The notion of an expert shouldn't really function as a limiting or a discouraging factor that closes off somebody doing research or somebody using analytical resources. But more technically, I think what we mean by expert is someone who has some sort of, or has a claim to some sort of epistemic authority. It's that simple. So, anyone who's been trained in a theoretically based practice, a discipline, a field would certainly be an expert by that definition. So any scientist or social scientist or, engineer, even though engineers aren't going to sort of use theories to try to understand nature, that's the typical stereotype, they still are trained in these things, and they exercise these knowledge-based practices, claims, and dispositions. All right. So in my notion, then, and any, you know, it's not just scientists and engineers and technicians. It's also judges, professionals, specialists, and even bureaucrats. Okay, because bureaucrats invoke epistemic structures. They say, well, you know, the policy is that you have to first fill out this form before I can answer your question. Okay, so we can view this as a form of epistemic authority or a claimed epistemic authority. So, you know, if we keep going, of course, we can push this and then everybody in the world is an expert because everybody has some epistemic authority. I know what my name is. Okay. And on some level, I'm fine with that because there really are no limits that I've discovered so far in, you know, a stir dyad or a stir group, like one person stirring a group, or even something that we haven't yet tried is one group stirring another group. I don't know if this is possible, but you know, stir is more of a dialogue exercise that can be done for its own sake, or it can be done for research questions, or it can be done in a stir 2.0 mode for normative reasons. And, you know, I think it's important to single out expertise or the specialist or the professional or the epistemic notion here, because we're really looking at a phenomenon that we could say keeps people from sensing the problematic situations they're in. And there's just been a lot of good literature on the limitations of expertise. And Evan Salinger has summarized a lot of that work and contributed to it wonderfully. You know, that expertise is both, it comes with power and limitations, right? The power of focus, but the limitations that you have to exclude things from your focus if you're going to look deeply. And so there's this sort of fundamental paradox to expertise that says the more I know, the less I know. And of course, again, to invoke Socrates, this goes back to one of the famous Socratic, you know, dispositions that, you know, all I really know is that I know very little. Okay. And, you know, Socrates' critique of expertise is that just because people know some things, they think they know other things, right? This is the fallacy that the dark side of Wigner's miracle. It's not, oh, I figured out how apples falling on the surface of the earth can help me understand the moons of Jupiter. Okay, that's a miracle. But if I say, I know how to solve equations, therefore I'm going to tell you the best way to fund science, that's not a miracle. That's not an extension. That's a fallacy. So I think that's, in a way, Anna, why we pick on experts, you could say, or we focus on experts, because there is this both power, a moral, epistemic, social, political power in expertise, even if it's disseminated many ways throughout society. And there's also a sense that there's a limitation. And it's, you know, people have talked about disciplinary specialization for a long time. There's other ways we can think about this. And maybe one plug that Puga and I are working on a paper that looks at a particular phenomenon, again, inspired by Socratic work, called amatheia. And amatheia is essentially the inability to be surprised. Or at least that's my quick gloss on it right now. And Puga can talk more about that here or in the future.
Okay, so we have a little bit more than 15 minutes left. So I would like to take one last question and then invite Erik to tell us a little bit about how his STEER research has moved on since the 2007 study. But the last question that I would like to raise is also from Anna, which I think is really interesting because it's about how do we communicate about STEER to different groups of people. She mentions here funding bodies, because of course, especially if you talk about open-ended inquiry, you can't actually promise any expected results, strictly speaking, but you might need to do so when you talk to a potential funding body. The same goes also when you talk to scientists. What can you tell them in terms of what the outcome of STEER is if you want to stay away from promising modulations? So what's your experience there? What can you say the method is doing without promising too much, but also without understating what it can do?
Yes, well, I think this is a great question, and I really appreciate the clarifying aspect, because, you know, the last thing I want to do is to say everybody has to walk around and use the word miracle. I don't recommend that we refer to things as miracles. at any stage of the research process, other than our own discussions when we're sort of playfully talking about how, what STIR is, how we practice it, how we can all get better at practicing it, why we might want to practice it. It's more of a sort of internal community, playful device. It's not meant to be a form of data analysis, and it's not meant to be a form of recruitment or proposal language. So I think we can be very clear when speaking to funding bodies that the STIR method is, very highly specified, and when it, to the extent that it's rigorously adhered to, there's an extensive body of empirical studies that show that it typically produces certain types of results, and these results have been, analytically formalized into the concept of a modulation, fitting into the midstream modulation framework, and they've been further broken down into 3 types of modulations, which tend to come in sequences, but only under certain conditions, and that since these are typical, if I'm speaking to a funding body and the funding body asks me or expects me to answer the question, what can we expect out of your study? I can say, well, STIR, modulations in STIR studies have been fairly typical. So it would be reasonable to expect that they come about. But if I'm writing a proposal to a body of theorists who, like Peter, are saying, we want to know why, these modulations occur, then I might say, well, invoking Wigner, that we're not sure if they're reasonable or not because we haven't really figured it out. As a matter of fact, they may be unreasonable. But only in that rare case would I say things like that, right? In 99% of the cases, I would like funding to do a STIR study because I want to investigate the capacity for integration in this area. Why? Well, because we have reason to believe that integration is not occurring on a widespread basis. It's not occurring on a highly reflexive, regular, and deliberate manner. Or if it is, we don't know about it. And we'd like to find out that it is. And if it's not, well, then we'd like to understand why it's not, and maybe think about what structural changes or management changes or pedagogical changes or collaborative changes could be put into place to improve this process or to broaden this process or to make it more anticipatory or more inclusive. And so the modulations that we expect to come from the study will help us answer these research questions. And if there are no modulations, well, this is data too, and these will help us answer the research questions. We could even, Anna, go as far as to say that since we expect there to be modulations, we expect there to be changes in practice, we expect there to be broadening of horizons, and that we expect, therefore, that we're going to not just be assessing integrative capacities, but as we're interacting with them regularly over time and they're expanding, there's going to be an expansion or a deepening or a change, maybe a building of those integrative capacities. And so, one could say that as a pedagogical method, STIR is likely to help inculcate certain virtues or practices or dispositions. But this is simply, sort of a statistical argument. It's done that in the past. It seems to work. We expect that it would happen again. But again, if the reason you're doing STIR is to bring about the capacity building, you're not doing STIR proper. You're doing something called STIR 2.0. You're forgetting the R in STIR. The research is not primary anymore, right? It's the intervention that's primary. Intervention for the sake of a political normative gain, as opposed to understanding capacities. Right? It's a subtle shift. It might not be obvious until you're done with your study, but if you find yourself promoting and promising modulations or the effects of modulations or what the modulations signify, then you're not doing STIR anymore. You're doing STIR 2.0. Now, there's nothing wrong with STIR 2.0, except that if you say that it's STIR when it's really STIR 2.0, that's what Pilkey calls stealth advocacy. That's like saying, because I can measure the level of carbon in the atmosphere, I can tell you which policies we need to enact to bring that down. Well, that's shifting from an epistemic to a political question very quickly. And it's not clear that that shift is warranted. And as a matter of fact, we can trace that shift, sadly, to a good deal of distrust in science, in my opinion, these days. because science has been instrumentalized and it has been politicized. And those who feel that they're being misled or being tricked or losing out have become highly attuned to this stealth advocacy. And so the last thing I would want is for STIR to be used in the mode of stealth advocacy.
Great, thank you. So do you want to tell us a little bit about where STIR is going now in your research and what you're working on?
Sure, let me just share a couple of slides. I really didn't prepare how I would share this with you, but I just wanted to tell you a little bit about a project that actually has concluded called STIR Cities, in which Jen Richter, Anthony Lavenda, and others, and myself, took 2 cities in the US, Portland and Arizona, and studied their socio-technical imaginaries, which was shifting down from the wonderful Jasanovian notion of socio-technical imaginary as a national phenomenon, you could say collectively held, bring it down into the regional level, if we want to say the level, even that is an analytical move that some would question. But we sort of explored these idea of regional imaginaries, and then we came down to what transition studies and MLP practitioners would call the micro level, and we looked at organizations and practitioners in those organizations in the 2 cities. And so each city had a laboratory. Each city had a commercial startup, technology startup, and each city had a sort of civil society or public policy organization. And we conducted 6 STIR studies, one with each of these 6 sites. And then we tried to make sense of any modulations that occurred in terms of what we called this idea of refracted imaginaries, and the idea of expert performances of regional and national imaginaries. And so we introduced this notion of an expert imaginary, an individual, right? This is a very different notion of, it's not a collectively held idea of the way technology works in society for the good of everyone. It's an individually held, expert-based imaginary that may be part of the expert's cognitive and affective and conative apparatus and tacit knowledge. And so, this is one of the modulation sequences we identified where engineers were going to put a battery on the side of a house where the utility wants it, but in doing a STIR exercise, the engineer acknowledges that, well, he could also think about the preferences of the homeowner, and then the engineer actually says, you know what, I don't want to talk to the homeowner, and then changes his mind and says, you know what, I think I should talk to the homeowner, and then actually talks to the homeowner. And not only that, there was an additional ripple effect where the engineers then changed where they located the battery as a result. So this is a nice little modulation sequence. And it's significant because the homeowner is participating in a demonstration, and the engineers are developing a demonstration. So the utility company is paying them and trying to control them so that they set up this demonstration for public purposes, so that the utility can then roll out these batteries, to their entire, or a large section of their user base, their consumer base. So not only is it a concrete decision about a socio-material configuration that changed, right, in this modulation, but it also has the potential to scale. And the change was really due at first to, Peter's question, the miracle, the reflexive broadening of the expert's contextual awareness, right? Now, this isn't a sufficient condition. Just because the expert broadens their reflexive awareness doesn't mean that they're going to do anything differently, but it's sort of a necessary condition, right? So the miracle has at least 2 parts. And this case in particular is interesting, and several of the other STIR cities project cases are interesting because there's a value conflict, right? The utility prefers one location, the homeowner prefers a second. And what normally doesn't happen is that the expert, the engineer, resolve the conflict in favor of the homeowner, not in favor of the utility. This is rather surprising in light of the history of engineering and the trope of the engineer as the frustrated moral agent who is sort of forced by contractual obligations to do things that are maybe subpar technically and maybe even normatively questionable. So we're claiming in this STIR Cities study that STIR engagements over time occasioned in more than one cases a broadening of the expert's socio-technical imaginary. Now, again, I want to remind everyone that this phrase, the expert's socio-technical imaginary, is a very, very different concept of a socio-technical imaginary, a national or collectively held socio-technical imaginary. So I probably should have even changed this slide to we can talk about different levels of socio-technical imaginary, and then we can keep the phrase. But if that confuses people and people somehow think that what I'm saying is that national enduring socio-technical imaginaries change and change because of STIR, then they're going to be misquoting me. So I really want to plead with people not to misunderstand what I'm saying here. I'm looking at something different from an enduring national collectively held socio-technical imaginary, which there's been a lot of work describing and applying. I'm looking at a new idea, which is this idea that individual people, individual experts can have imaginaries, and those imaginaries can be impacted and changed. So that's just a quick little teaser on some of the work that we've been doing.
Great, thank you. Yeah, I'm looking forward to seeing the paper coming out. And I also just want to end our session for today and say thank you all for participating. Next time we'll meet in June on the 23rd, which is a Thursday. We have a different time slot because we have a speaker from Australia, Bastien Miorin. And the talk will be at 3 p.m. Arizona time. So unfortunately, that's midnight in Europe. But of course, there are recordings on our website. So feel free to watch it afterwards if you can't make it at 12 p.m. at night. So yeah, I hope you can join in June. Otherwise, we continue in July with Anthony Lavender. And yeah, I hope you all have a good evening or a good day, depending on where you are.